Hello everyone and welcome to Coding Card. So in our previous session we have solved this problem connected components count in an undirected graph. So we have used DFS approach where we were traversing node by node in the graph, and for every node we were traversing all its neighbors. So once all its neighbors were traversed, we were increasing our count by 1 and moving further for the next node. And we have also used this visited set where we were keeping all the visited node so that we are not going to visit again if any node was already visited. So in this session we will be doing a follow-up question, that is print all the connected components. So previously we have solved how many connected components were there. Now we need to print all the connected components as well. So for example, so we have a node 0 which was connected to node 1, this was connected to 5, and this was connected to 8, and 8 was connected to 5, and another was 2 was connected to node 3, and 3 was connected to 4, and 2 was connected to 4. Yes. Now for example, let's take one more, a single node 6. So if you see this, you can find here 3 connected components. One is this one is this, and another is a single node 6. So there are total 3 connected components. Now for every connected components we need to print the nodes as well. So if you see here the connected components nodes are 0, 1, 5 and 8. For this we have 2, 3 and 4, and for this one we have single 6. So we need to print all these nodes, means connected component nodes. So this is the problem. So this is very simple, like in the previous one. So this was our previous logic to find connected components count, where we have used DFS approach where we were traversing node by node, and for every node we were checking that node is present in visited list or not. If it is not present, then we were going for the DFS, and in this DFS function we were again recursively calling the DFS for all its neighbors present for that node in a graph, right? So we will change the logic little bit here only, like when we are going for the neighbors in a graph, we will simply add all the neighbors in a list. Okay, so once all its neighbors are added in a list, we will simply, so when we were coming back here we were increasing the count here, so we will change this logic here. We will simply add this list in another list. So this list will be added here. Again we will go for the next node, it will go for the DFS, it will go for the DFS for all its neighbors, and again it will come with a list of its connected components we will add here, and at the end we will print this total list. So this is the approach. So let me explain you. So for example, suppose we are given a graph. Let me take a sample. So let me take a sample. So suppose this is my graph. Okay, the same graph which I have explained you here. So what we have to do here, graph is given, we have to write our logic. Now we got the graph and we have our code here. Let us copy this one, we will update here only. This was our code. So this was our code to find the connected components count. So we will update here only. So let us change this function name with list connected components or print connected components. Alright. So we will start from here. So let us first call this function print connected components, and let us pass this graph. Okay, so this function will be called here this function will be called. So the logic will start from here in this function, line number 11. Now we are taking here a visited set. This is a common for adding the node which are already visited. We will remove this count with components. We will take one list. So this is a list, and this list will contain all the list which are being traversed one by one, all the connected component list. Now we are going to traverse node by node in a graph. So this here, this is a graph. We have node 0, 1, 5, 8, 2, 3, 4 and 6. So we are starting from here 0. So if node not in visited, so this 0 is not in visited. Yes, currently we are starting with 0 only, so this is not present. So we have to go for the DFS traversal for this node. So before that, we'll change logic here. We will pass one component with an empty list. So this is components and this is component. So or for example, I mean to say that components is this one. This components is this, and component and components are component are this single list. All set. So the single list will be all the neighbors, the current node and all its neighbor. The current node on which we will be standing and all its neighbor. Current node and all its neighbors. This all will be added through the recursion. So we will create one empty component list component, and in this DFS traversal we will pass node and this component. Okay, all set. So we have passed this current node and this single component where we will add all its neighbor. Now once this DFS is done for this current node on which we are standing, so after this we will append components dot append this single component which is holding all its neighbor of the node on which we were standing. All set. So this is done. For example, if I explain here, we started with 0. Suppose this is the node 0, 1, 0, 1, 5 and 8. 0, 1, 5, 8. Yes. So we started with 0. So this is our components. So we are standing at 0 and we passed DFS of current node, that is 0 and a empty list. So what this DFS function will do, it will add all its neighbor along with it 0, 1, 5 and 8. And once this DFS is over, we are going to add this list in the components. So this will be added here. Now let us change the logic for the DFS call. Very simple. Like here we are giving two things, node and component. Now if the node is in visited, we were simply returning, otherwise we were adding in the visited list. So once we are adding in the visited list, at the same time we are going to add component dot append that current node as well. So it's like for the current node we are marking it as a visited, and at the same time we are adding in the component list. Now we are going for all its neighbor. So for neighbor we are again calling the DFS one by one by passing the component, so that in the same component list all its neighbor will be appended. So once we are done from this DFS traversal and this node one by one, at the end what we have to do, we got the final. So at the end we got the final components list, this one, which will hold all the connected component list one by one. With the help of this for loop we are traversing one by one node every time, and with the help of this function we are traversing in its neighbor one by one. Now let us write logic to print for component. Let us take the same value, component in components. We have to simply print component, right? Or also we can print here print components. Let us run and see. So you can see here the components S, the list is holding single component 0851. The second connected component was 2, 3 and 4, and the last one is single node 6, and these three are we have printed with the help of for loop, this one. So I hope you understood this one. Let us take another example. For example, if I am removing this one, so it will print only two things, right? This one and this one. So you can see here the components is having these two component list, and this is the output for the for loop. It's again 2. So the logic was quite simple. This for loop was for traversing node by node. So here we are passing for every node on which we are standing, we are passing one single component list so that we can add all its connected neighbor. And in this DFS we have simply written the logic to traverse all its neighbor and append in this component list, and this everything were taken care recursively. So I hope you understood this problem in a very simple way. So if you have learned something new, do like our videos and subscribe to the channel Coding Card, and stay tuned for the next video. So in the next video we will be solving the same kind of problem where we will find the largest component. So for example, if you see here in this graph where 6 was also present, 6 was also present. Let me comment this one. So there were 3 connected components. Now we have to find the largest component. So we need to find this one 0851, and we need to print the length of this largest component. So we will solve this in the next session. So stay tuned and thanks for watching.